through our laptop and it won't boot. And then we came in here and we tried to present and it wouldn't present. But we come to security conferences a lot and we talk to security researchers. And a lot of times they have.
Only 2 seconds. We are recording.
Okay.
Just hand it off for now.
And a lot of the questions they have is, hey, how come your security updates take so long? I gave you this bug 3 months ago. Why isn't it fixed yet? So we're going to kind of go through, end to end, all the stuff we do, and kind of give you our philosophy on updates. And the best part of this whole thing, at the end, we're going to go through 2 real bulletins and give you the blow-by-blow, what we did, which day, how long it took, when we got the bug, when we released the update, when we released the advisory, what went into the advisory, the whole thing. So that's really going to be the best part of this talk. So you'll have to kind of struggled maybe through the first half of it while we explain the base foundation for that, but that's going to be really good at the end.
All right. Yeah, so the best part is actually coming up. But before we get to that part, though, kind of want to walk you guys through some of the processes that we go through. And we'll go through some of these boxes in more detail as we get through the stuff. But in general, it kind of starts off with the MSRC PM roles on the top orange boxes and the engineering teams on the blue boxes down here. There's kind of a lot of data in here, but we'll kind of hit this up at a really high level. If most of our bulletin processes start off with vulnerability reporting, and hopefully it was responsibly disclosed and we just didn't become aware of an issue from different ways. And it'll come in via secure or whenever we're made aware of a vulnerability. And MSRC will wind up opening up a case in Microsoft and getting the engineering team spun up on that. The next portion of this is the investigation and the triaging portion. This is where the engineering teams as well as the product teams actually take a first crack at the vuln and really try to assess the severity for customers as well as the impact of the vulnerability to systems. The third part here is where it's managing the finder relationship. And this is where it's more of an MSRC Operations PM role where we kind of maintain relationships and nurture relationships with finders and security researchers. That way we kind of keep them coming back to us at responsibly disclosing vulnerabilities instead of going down different paths. And then the engineering folks kind of swing up on the fix validation side. This is where they look at the vulnerability, look at the fixes that they have, and Mark and Jonathan can actually get into more detail on that stuff. The next boxes over are the content creation and the technical guidance. And this is how we go about creating our communication stuff, things like bulletins, advisories, KB articles, or actually these guys, they do the SWI blog or the MSRC engineering blog. Sorry, they just changed their name there. As well as MAPP guidance and some of these programs that you guys might be aware of. And the last portion here that we're covering is the release process, where we actually have second Tuesday, like yesterday, where we actually release the bulletins as well as the updates, and they'll go out through the automatic update channels like automatic update, Windows update, Microsoft update, and the download center. And the last box down here on the bottom is update dev tools and practices. This is kind of another area where the MSRC engineering folks make sure that we kind of don't wind up on this treadmill over and over again. They'll take the tools that they use to triage and go through some of the security processes here and apply them for future vulnerabilities, as well as to make sure that the newer products are better than or are more secure than older ones. So as far as operations program management stuff, that's kind of what I do, where we wind up working with finders, reporting vulns that come in. We coordinate the vulnerabilities that get reported to us with the engineering folks, MSRC engineering, as well as product teams that have the affected code base. So things like GDI plus or kernel will wind up going to like the Windows sustained engineering team versus Office vulnerabilities that go to a different team, or IE that goes to a different team as well. And so from an operations perspective, the MSRC PM winds up coordinating the vulnerability with the affected component team, as well as works with the MSRC engineering teams. And one of the other things that we wind up doing is whenever we get vulnerabilities reported to us initially, we start our messaging plans. And a lot of the messaging is what is the appropriate ship vehicle for an update, if the update actually even warrants a bulletin update, things like that. And a lot of this is around advisories, bulletins, KB articles, and at the MSRC blogs as well. And one of the final things that we kind of do as well is we coordinate severity ratings for MSRC bugs. So the severity ratings are kind of interesting because, especially now with the exploitability index, so typically you'll have a severity rating of either critical, important, or moderate. Every once in a while we'll do a low or defense in depth bulletin. It's kind of rare. But critical usually implies that it's a remote code execution vulnerability that requires little or no user interaction. Importance usually rate to like a local elevation of privilege or a system DOS, that kind of thing. Moderates are usually around info disclosure or application DOSes around there. And defense in depth fixes or low fixes are kind of ways to where where we add security functionality that users can wind up using. So most of our cases wind up starting off with a vulnerability reported to us, or where we become aware of a vulnerability. For MSRC PM, the majority of the time that we get vulnerabilities is through secure@microsoft.com. And that's where it's an open email address where anybody can report vulnerabilities to us. And it's actually pretty successful, and it's where we get most of our vulnerabilities that we wind up releasing in bulletins. We also have other channels. We have a lot of partners who are out there looking for vulnerabilities, as well as the engineering folks who are kind of trolling through a lot of different interesting places to find vulnerabilities as well. So that kind of speaks to the honeypots, as well as coming to conferences where we talk to other security researchers and we find out what vulnerabilities people are interested in. And from as far as managing secure@microsoft.com, it winds up being a 24/7 kind of operation where, and for typically we wind up getting a response back to finders or security researchers within a business day of them actually reporting vulnerability to us. It can be pretty daunting sometimes, especially depending on what finders report to us. We get a range of reports, some that are extremely detailed, where they'll give us dumps and crash data, a nice write-up, the implications of the vulnerability, and sometimes you'll just get like a really high level, hey, I think I found this crash and I think it's exploitable. You guys figure it out, And so it's kind of a range of things, and but typically we take every single one of these emails seriously. There's actually a human that reads every single one of these emails, and we go ahead and respond to everybody within a 24-hour time period. So typically on Secure, we'll wind up getting about 150 to 200,000 emails a year, which aren't spam, which we actually respond to. Out of that 200,000 emails, we'll wind up getting about 1,000 MSRC cases. And out of the 1,000 MSRC cases, we wind up getting between 75 to 80 security bulletins a year. So that's a pretty significant tapering down of what's reported to us to what actually winds up being a security bulletin. And the majority of it is because we get some interesting mails, right? And we get some really interesting mails, actually. So like two of the examples that I put up here is of the stuff that doesn't result in a security bulletin. So like this guy reports that, hey, I locked my computer screen, but you can still hit the power button and DOS my machine. So that one didn't get addressed in a bulletin. And then this other woman reports that every time she goes to a chat room, she hears doors opening and closing, which apparently in her mind was a vulnerability as well. Yeah, it was kind of interesting, right? And my favorite ones are the ones that are like, hey, I heard Bill Gates is going to email me a $10,000 check if I forward this mail to all my friends and family. I'm pretty much, I promise you, Bill Gates is not going to send you a mail for $10,000 for spamming your friends and family with malware. But yeah, it winds up tapering down pretty significantly. So another one of the things that I kind of mentioned earlier was the exploitability index and severity ratings. The main reason that we do severity ratings in our bulletin is to allow customers to make their own risk assessments for their environments. So before in the past, we used to basically just tell everybody all of our updates are super important. Go ahead and take them and deploy them as soon as possible, right? that doesn't really scale well to enterprises who are who really want to make their own risk assessment for their own environments. So our severity ratings and bulletins are kind of the worst case scenario for that particular vulnerability that the bulletin addresses. So if you get a critical class vulnerability in a kernel bug or a certain kind of process or protocol bug, then we'll mark it critical because that's the worst case scenario for that bug. However, when enterprises look at that vulnerability or that bulletin, they'll be able to look at that and go, well, I don't run this protocol in my environment, therefore it's not applicable for me. And so the worst case scenario is what we mark the bulletins as. But out of all of this comes the exploitability index, which we started off in October or September of this year, or last year. And the exploitability index is kind of a measure of what's the true likelihood of this vulnerability being exploited within the next 30 days of release. And the next 30 days of release is kind of important because whenever we release security bulletins, there's a whole community of people who basically reverse engineer our updates, and they go from patch to exploit pretty quickly. And so looking at what our vulnerability or our updates actually patch, it's pretty important that we give customers a realistic expectation of how likely exploit is able to be developed for that vulnerability. And the exploitability index is something that we do every month for every bulletin, and it's part of the bulletin summary page that goes along with the bulletins as well. And kind of wanted to bring up an example here. This is Bulletin 09001, the SMB bulletin that we did in January of this year. So the bulletin actually had a critical severity rating because it was a kernel, or it was actually a memory corruption issue that, when you looked at it, it looked pretty bad and theoretically could allow remote code execution. And honestly, like certain security researchers can wind up spending tons of resources and time to actually look at this vulnerability and actually get to remote code execution. Possibly. It's theoretically possible. But the reality is, like, we had a lot of smart folks like Mark looking into this for quite a while and really saw that it was pretty difficult to do. So we gave it an exploitability index rating of 3, which is very highly unlikely within the next 30 days to actually find a security vulnerability that could actually exploit this. And another portion of the outreach and communication stuff, that we kind of have 3 phases. One before the bulletins go out during the bulletin release time frame, and then the post-release time frame as well. Before the bulletin goes out, the Thursday before the bulletin release on Tuesday, we wind up putting an advanced notification out there, which is basically lets enterprise users know that, hey, next Tuesday, there's either a lot coming down your pipe and you're gonna have to do a lot of work, or there's very little coming down your pipe and this is how you need to prep your environment. That way it's not a surprise on Tuesday. We also do MAPP notifications, and Jonathan will kind of go through a little bit more of what the MAPP program is, but it's basically advanced notification to AV vendors so that on release Tuesday, they're not cranking up trying to develop new signatures and everything else. That way the entire security industry is kind of synced up on release Tuesday for the vulnerabilities or the updates that we release for those vulnerabilities. On the second Tuesday, I think you guys are pretty familiar with that. You wind up getting all the updates out on the update centers, the DLC, as well as you'll have your bulletins, your bulletin summary, and depending on the vulnerabilities that are addressed, we'll also wind up having possibly the MSRC engineering blogs as well as an MSRC blog. There's RSS feeds as well as notifications and things like that. And then post-release, on Wednesdays, actually, which I'll be doing here in a little bit, after our bulletin releases on Tuesdays, every Wednesday we have a webcast, and anybody can log into the webcast and ask us questions. We have a room full of guys who just basically sit around and go through every single question that comes in, and people on the webcast can listen to the responses for their questions. Depending on how busy it gets, webcasts usually last about an hour and a half, but for instance, like the Net API vulnerability that we had a couple months ago, we had to do, I think, 3 separate webcasts with which ran a couple hours long each. I mean, there was a lot of questions, a lot of concern about that. And we'll do whatever we can to make sure that we answer questions and concerns from all of our users. And I mean, we also do things in post-release as far as monitoring the bulletin uptake, the uptake of download centers and things like that, to see what the uptake is for the fixes for our vulnerabilities as well. That becomes pretty important, especially, for instance, in light of recent events where we had our out-of-band release for Net API. We were really hoping that people would pick up on that more than they actually did. But so I kind of touched on most of the stuff that's on the top row there in the orange boxes, which is kind of the MSRC Operations PM role. There's a lot of these things that overlap between the engineering field as well as the operations PM as well as the product team. But in general, it kind of goes into that. And I think Mark's going to wind up talking more about the MSRC engineering side.
So, yeah, as Dave said in the intro, my name is Mark Wodrich. I work in the MSRC engineering team, and I work in kind of a subsection of that team that primarily deals with the initial investigation and some of the kind of front edge work that we do for cases. And Jonathan is going to talk a bit later about the mitigations and workarounds and some of the other technical guidance and information that we share with partners. But I'm going to drill down into kind of the first two boxes that you see on the bottom of the slide here. So when the issue originally comes into MSRC, they open a case and basically kick it over to the product team and to my team, the engineering team. And both of us in parallel then start working, trying to reproduce the issue internally, just basically trying to see if we can recreate what the finder saw and start analyzing it to see how severe it is. If we have enough information from the finder, usually the repro can be done pretty quickly up front. Sometimes you'll get a report where the researcher has spent a lot of time, they've done a write-up, they probably have disassembly that's been annotated, or they might have crash dumps that they've provided to us. So it can be quite easy to do the repro and see that the issue is valid. But sometimes you get a report where the finder doesn't spend a lot of time digging into it, or maybe they don't have the expertise to really analyze the issue very deeply. And we may need to go backwards and forwards with the finder to get more information and kind of build up the understanding of the issue. And we do that through the MSRC PM as sort of our liaison to the finder. Anyway, once we have enough information and we've been able to reproduce the issue internally, then we can start looking into what the root cause of the vulnerability is. And we do this basically to make sure that we understand, what the actual bug in the code is, and then we can start thinking about, do we need to start looking for a general class of issues here, or is this just like a one-off implementation bug? Are we going to have a huge number of similar issues in the code? Have we seen this kind of thing before, or is this totally new, and do we need to start thinking about new tools or new approaches to kind of deal with this type of bug? So once we have that, we also look at gathering some additional technical data like network captures, stack traces, and this information is all saved in our internal database so that we can share it later on with partners. We then also do our own evaluation internally of the severity of the issue to figure out if we think it meets the bar for a security update. And we work with MSRC to make sure that sort of internally at Microsoft we kind of agree on the severity, and we can then go back to the finder and say, yep, we're going to fix this in a bulletin, or no, we don't think this is worthy of a bulletin. Maybe it's a service pack issue or not really a security issue at all. So once we have the issue reproduced, we then move on to this phase we kind of call hacking for variations. And the aim here is to basically make sure that when we release the update, it addresses all of the issues in the code that are related or might easily be found by external researchers. We don't want to kind of be in the position where we issue updates back to back, for the same binary or the same product, and play whack-a-mole with issues. So we spend a lot of time making sure that the update is solid and try and fix as many issues as we can. So the way that we do this, we kind of use a bunch of different approaches. The first one is to look at the source code and review it to see if you can find other instances of the same reported vulnerability in the code that you're fixing anyway as part of the update. And that kind of then starts expanding in scope. Once you've looked at the original module or product that was affected, you might start looking slightly wider and saying, okay, we know that we had an issue in JPEG parsing, so let me look at other bits maybe in Windows that do JPEG parsing and see if they're affected by the same issue. So you start increasing the scope of your source code review. Once you've looked at that, you can even go wider and you can say, well, I know at Microsoft we have a bunch of different products that parse JPEG images, so maybe Internet Explorer has code that's affected. Let me look at that code. And basically, we end up looking at all of the Microsoft products that could be affected by the reported vulnerability. So the finder might think that they've found a single issue in a particular component. When we do our internal investigation, that can actually expand into a really big update that affects a lot of different products across the company. And that's one of the reasons why sometimes it takes us a while to do the investigation and actually get the update into the stage where we can start thinking about fixing it. We also look at some of the bugs that were found by the product teams as part of their regular testing work. And quite often you'll find that if a vulnerability is reported in a product that's been out in the market for a while, internally the product team have been working on the next version of that product. They've been using the SDL, which is continuously updated, and they have probably improved the testing and also the tools that they're using to find new security bugs in their product. So the bugs that they've been rating in our database or in their database might actually apply to the update that we're thinking of releasing. So we kind of triage all of the bugs that the product team have found and see if any of them are worthy of including in the update. Then we kind of move on to using automated tools, and specifically fuzzing and static analysis. The fuzzing is obviously widely used outside of Microsoft to find bugs, and we try to make sure that whenever an issue comes into us, we figure out whether it could be found through fuzzing. If there's any kind of input data that's being processed by the program, like an image file or a document by Office or whatever, usually that kind of bug should be able to be found through fuzzing. And we have a bunch of internal tools that we use that have been developed over the years that we can kind of customize and apply to different file formats. So if the issue comes in, the first question is, have we seen this already through our internal fuzzing? If we have found it, then okay, that's probably good. It's probably fixed in the new version of the product, and we can kind of do some additional fuzzing, but we're in a pretty good place. If it hasn't been found internally, then we need to ask ourselves why that is. And usually that means that our internal tools were either not configured correctly, that they weren't going deep enough into the code to hit the issue, or maybe we didn't have the right tools to do fuzzing and find the issue. So we need to actually go and prototype and develop new tools that can hit the issue. And our team actually does some development work on new tools like that. So we always make sure that any tool we develop can actually find the reported vulnerability up front. And once we've done that, we know the tool is at least good enough to find the external issue, and then we keep running it to see if it finds additional variants. So the last sort of tool, automated process that we use is static analysis. This is basically using tools to scan either source code or binaries and trying to identify bugs or defects in the code. We have internal tools, again, that we can use to do this. And similar to fuzzing, if those tools don't work or are not able to find the reported issue, we can then improve the tools internally or develop new tools and try and kind of customize things to find the reported issue. I mentioned later how we kind of roll back these improved tools into the company and make sure that they get picked up externally. So the tools don't only stay in our team, they actually end up having a wider influence as well. So then the final kind of phase that my little sub-team is involved with is actually testing the fix and making sure before the bulletin goes out that it's complete, it works correctly. We do this basically by reviewing the fixed source code and making sure that what was implemented matches the sort of specification or the design for the fix that we came up with the product team. And then we also have a look at the fixed binary and make sure that it works correctly and handles both the external issue and any internal variants that we found through our process. And sometimes there'll actually be a difference between the source code and the binary due to compiler optimization or macros and things. So we find that it's important to actually, obviously test the binary as well as the source code. You can't just do a code review and think, okay, everything looks good. My team also does kind of technical review of the MSRC bulletin, making sure that the vulnerability data and the sort of attack vectors and all of the technical information in the bulletin is correct. And we then also think about ways that we could share additional data with customers when the bulletin goes out on Patch Tuesday. So quite often the MSRC bulletin is kind of high level and kind of gives you an executive summary of the vulnerability and whether you should deploy it. But we can give you more technical data that helps you prioritize whether you need to deploy the patch immediately, or possibly this doesn't apply in your environment. We basically give you more data to weigh into your assessment of deploying the update. And then, as I mentioned on the previous slide, we have improved tools that we come up with in my team. So what we do is we make sure that the SDL and the tools team that we have inside the security team are aware of those changes, and they can roll them into the standard tools that all of the product teams across the company use as part of the SDL process. And this helps to make sure that the future versions of our products benefit from any kind of security learnings and improved automation that we can come up with as part of MSRC bulletins. So I think I'm going to hand off to Jonathan now. He'll talk about the mitigations and MAPP data.
Thanks. So Mark's team is really focused on the fixed bits, the vulnerability, finding variants. We have another group that kind of in the MSRC engineering team that kind of comes in halfway through that and looks for different ways that we can help protect customers when they can't apply the update right away. So some like banks and hospitals and whatnot sometimes have regulations where they have to do months of testing before they're able to apply the update. So we have a couple ways that we can help people not get owned during this process. One of them is mitigations and workarounds, and the other is a partner program we're going to talk about here in a second. So we started about halfway through this process that Mark talked about. So we have a repro from them. We know what the root cause is. So we're specifically focused on ways that we can help customers be protected even if they don't apply the update. So we can start with the crash dump or the repro, whatever Mark's team gives us, and look at the call stack, and we can see right away, hey, this is in a module, this is in like an ActiveX control, we can apply the ActiveX kill bit. We can put that in the bulletin. Or, you know what, this is in a DLL that's not critical to the system booting, so it may degrade functionality, but really you could unregister this DLL or unregister this module. Or, this is, if we can ACL off a file and protect you from this vulnerability. So that's one way we'll start with, looking at the process flow. We'll also look at the source code. Now, we might see from analyzing the source code, hey, there's this check if for example, the Far East Asian language pack. If the Far East Asian language pack is not installed, you don't go down this branch. So we can say, you know what, you can unregister the Far East language pack for a temporary workaround until you're able to apply the update. We also get good ideas from the product team. So we just released an S-channel update yesterday, actually, and the product team had a really good workaround idea, and we put that in our blog, so you can go off and look at that if you want. And then we've been around for a while now, so I think next week I'll have been in this role for 6 years, so we've seen a lot of vulnerabilities, and we know our products pretty well. So we see things like, in Vista they added an RPC endpoint firewall. So we can give the netsh command that lets you ACL off a specific RPC endpoint. So since we know that about the product, we can generate those workarounds, test them, make sure they work, and then hand them off to Dave's team to put in the bulletin. And we'll also look through, we'll go through the crash in Process Monitor or some dynamic analysis tool, and that's going to log every single API call that the product makes. It'll look at every single reg key that it tries to open. And sometimes there's real gems in there, like, if this file doesn't exist, or if this file can't be created, you don't go down this code path, and Process Monitor shows some of that stuff. So we can make a workaround. Hey, just pre-populate this file, and you can't get owned, or set an ACL on this registry key, and you can't get owned. And in the brainstorm, actually, we come together as a team to talk about mitigations and workarounds every Monday. So each person goes through the cases that they think they're done with, and we brainstorm as a team different ways we could have a mitigation or workaround added to the bulletin. So that's one way that we can protect customers who can't apply the update right away. The other way is actually working with partners. So we have this MAPP program we introduced in Vegas last year at Black Hat. The MAPP program is a Microsoft Active Protections program. It's really AV vendors, IDS vendors, IPS vendors. I think the criteria is something like, if you have a commercial product that protects 10,000 or 50,000 or some number of customers, you qualify to be in this program. You send an application to us, we review that you're a legitimate company and you don't write hacks for tools and whatnot, and we add you to this list. Now, every month before Patch Tuesday, we send a package for each CVE that we're fixing to all our MAPP partners, and it has a bunch of stuff that helps them generate good signatures or good, detections or whatever all our partners can generate. We start by giving a repro of the vulnerability. Now, this is something we generate ourselves from scratch every time. So we don't, if we get a vulnerability from a researcher like you guys, we don't just pass that off to all our 50 MAPP partners or whatever. We start over. We understand the root cause. So we can even, a lot of times, generate a cleaner repro that more precisely hits the vulnerability to help people understand the vulnerability better. So all our MAPP partners should be able to reproduce the vulnerability without having to reverse engineer the package. It saves them some time. And then also we give what the boundary conditions are on that bug. Like say for like an integer wrap vulnerability, our repro might have FFFF as the value we're using, but we know from looking at the code that FFFD and FFFE are also vulnerable. So we'll just give the whole what the exact boundary is there, so that AV vendors can write really strong good signatures. And then as we're going, Mark was telling you about the database we keep. So as we're going through the investigation, we keep notes. And we'll just sanitize those notes and build kind of just a free-form text to help people understand the vulnerability. The bulletin is sometimes at a high level, so we share deep technical notes with our MAPP partners to help them understand the vulnerability. Let's see. Oh, and then some MAPP partners, like IDS vendors, a lot of times find event log entries or any kind of exploit indicator, something that indicates that an exploit has happened. They find those useful. So we'll capture what the event log looked like. Anything that would have happened had an exploit occurred, we'll capture that and put in this exploit indicator section. And usually all that is actually good enough to help people build good signatures, but we really want to be sure that the bug that our partners are detecting against is the bug we're fixing and it's not some other thing. So we'll also we'll generate a stack trace with public symbols and dump the assembly and then show which version we repro'd on, just so we can make sure that our partners are hitting the same bug that we're hitting that we wanted them to protect against. So that's for detection guidance. Okay, so finally we got to the case studies. This is going to be really good. So we're going to talk about two cases. One of them was in band in our regular security update. This one came from a trusted finder, Thomas Garnier. It was a win32k.sys case. And it was pretty clever. He was doing something that we hadn't really seen done before. So we wanted to go through the full comprehensive update, all the app compat testing, the whole deal. And Mark's going to talk about what that involves. And that took about 6 months to fix. The second one came in, I'm not sure, these bulletin numbers are burned into our heads, so maybe everyone doesn't understand, but MS08078 was the IE0 day from December. So that obviously came in different circumstances. We found out about this one as it was being exploited on Chinese malware sites, which is a bummer. So we'll talk about how the timeline was different on that one, and I'll break down what we did every day. We got that out in 8 days, and we released an advisory, and we revved the advisory like 3 or 4 times, and I'll tell you, kind of give you a screenshot of some of the communications we did. So Mark is going to come up now and give the first case study.
Right, so as Jonathan said, MS08025 was a vulnerability that affected the win32k.sys driver in Windows. And we had a case that got opened based on the original information from the finder on October 24th in 2007. So pretty much as soon as that came in, my team started working on the internal repro on the 26th. And because Thomas Garnier had given us a lot of kind of technical info and done a lot of work himself, the repro was pretty easy for this one. He gave us actual POC code that you could run, and it would demonstrate that he could execute code in the context of the kernel. He didn't like put shellcode or anything in there. He just demonstrated, hey, I'm executing code from my buffer. This is bad. So it was actually pretty easy to get the repro done. We did that within 2 days. And determining the root cause as well was pretty easy. On the 26th, we were also able to validate that we knew what the root cause was. And Thomas had actually analyzed the disassembly, and we could just check that our understanding of the issue was the same as his based on what he had seen from reverse engineering the code. So then we started doing, assessing the severity and attack vectors. This pretty much is done also on the same day for this kind of case because it's pretty obvious. This is a local attack. If I can run code on the machine, I get code execution as the kernel. It's a severe local elevation of privilege. We knew what the attack vectors were. So then we start doing the hacking for variations work, and you can see that there's a couple of dates that pop up in green. The first one is on the 31st of October, and this was basically a source code review that found a close variant of the reported issue in the source code, and we could do that pretty quickly just by looking at the code for Win32K. We kind of realized, looking at the code, that this is a huge component. It's very complicated. It's been around since day one of Windows NT, and it's going to be really hard to do source review to find all of the areas that could be affected with similar kinds of bugs. So we realized that we needed a tool to try and find other variants, and an obvious approach would be to do some fuzzing to just send bad data down and try and find other bits of code that had a similar vulnerability. But unfortunately, we didn't have an internal tool that could do this kind of targeted fuzzing for Win32K. So we realized that we needed to actually invest and develop a tool that we could use for this process. So that's kind of explaining why there's this kind of long gap through November and December. And this is basically our team taking the time to design and implement the fuzzing tool for this case. That tool started paying off in sort of mid-January. On the 11th, we found a fuzzing variant using the tool. And then again, at the end of January, we found another variant. So one thing to realize is that the fuzzing process can run for quite a long time. It's kind of hard to know with fuzzing when you're done, because you're just generating kind of random data in most cases. And you can look at code coverage. You can try and get a feel for, have we exercised as much of the code as we think we can? But it's not always possible to say, yep, we are not going to find any more bugs here. We're done. So we usually keep the fuzzing tool running as long as we can, right up until the bulletin goes out. And if we find anything at any point, we can reassess things. So when the original bug came in on the 11th, obviously we kicked that over to the product team. We look at it ourselves, and we try and say, is this as severe as the original issue? Do we need to fix it in the update? If so, then tell the product team to include this in their fix. And that happens again when we found the other variant on the 31st. We kind of have to reset things and say, okay, let's look at this variant to make sure it gets fixed. It kind of keeps extending the end goalpost for when you can ship the update. So now we hand things over to Jonathan's team, and Jonathan and his team basically look at mitigations and workarounds for the case on the 15th of January. At this point, we understood what the basic issue was. Obviously, we're finding internal variants through our fuzzing tool, but that doesn't really affect the mitigations and workarounds part, and that can happen in parallel. So by the 4th of February, we kind of felt that we had found all the variants. We weren't finding kind of new issues through the fuzzing, and we could agree on the fix with the product team and kind of make sure they moved ahead with implementing it. Then once the product team has the source code updated to fix all of the variants in the reported issue, our team basically reviews that fix and makes sure that at a source level it looks correct. And you'll also see underneath February there's this thing called depth test pass that has popped up. So this is something that happens external to the sort of MSRC team, and it actually is part of the Windows Sustained Engineering, or WinSE, test process for Windows. Because Windows is so big and has so many components in it, we don't, basically we can't afford to do a short kind of test pass where we only test one little component at a time for a security update. And the way the Windows SE team approach testing Windows is basically breaking it up into two passes. The first pass is the depth pass, and that basically is kind of a targeted test just for the component that is being updated in the fix. In this case, it's Win32K. And they basically make sure that all of their functional tests succeed for that component, and they haven't regressed and broken anything in that area. So it's kind of like a fairly focused look at that one component, making sure it's still okay. Once the depth test pass is done, let's see, we move on. We do our functional test, so actually the depth test is still happening sort of in parallel with WinSC. Inside the MSRC engineering team, we do our test on the binaries and make sure that they work correctly and handle all of the variants that we found. And then let me talk about the broad test pass first, which is happening in March now. So basically, we spend 1 month on the broad test pass. If that succeeds and everything looks good, it then moves into the broad pass for another month. And this is where we basically have all of the test teams that test Windows pick up that fix and make sure that their particular functionality and their component doesn't break. So, the printing team will pick it up, the GDI graphics team, all of the different sub-teams within Windows, networking, they'll all pick up the Win32K.sys change and make sure that nothing is broken in their functionality. So because we have this 2-month test process for Windows, this basically means that if we find any issue either during the depth test pass or the broad test pass, we kind of have to reset things and push the bulletin out to the next 2-month window. And we only ship Windows updates every second month. So sometimes, unfortunately, we might find either a regression or maybe we find a fuzzing variant internally that causes us to reset and slip a bulletin out due to this long test process we have. Anyway, assuming we haven't found anything, in this case we didn't, we do the bulletin review on the 31st of March. We did that, basically review the technical content in the bulletin. And at this point, we're kind of ready to sign off and ship the update on the next Patch Tuesday that comes along. So here we go. We shipped it on, was it the 8th of April? And yep, at this point, we're now kind of back to MSRC Ops, and they watch the uptake and monitor the bulletin once it's out there. So that's the end-to-end process for a regular GDR update or security update that takes usually a couple of months to do for Windows. So Jonathan is going to talk next about the 08078 0 day for Internet Explorer.
Thanks. So one thing you might see from this, we're really optimizing in this process for compatibility, make sure we don't break anything. When I started in like 2003, we released every Wednesday. Every Wednesday we had a GDR release, and then we'd spend the rest of the week cleaning that up, and the next Wednesday, often we'd have to re-release the same update. And customers came to us and said, hey, you're killing us. We're releasing all these updates. They're breaking all kinds of stuff. You guys need to get your act together. So then we switched to this really a focus on compatibility and not breaking things. And yeah, it ends up taking longer, but that's kind of our emphasis and kind of the philosophy in our servicing for stuff that we don't think is being exploited in the real world yet, which is this one. So let me get my notes here. Yeah, so we found out, actually we didn't find out about this. We found out later on December 7th of last year, there was a 0-day vulnerability posted to a Chinese message board. And it was full on like working exploit, the whole deal, downloads malware and runs. It was pretty bad news. So we weren't actually monitoring that, but we found out we have a group in China that's associated with the MSRC that watches that kind of thing, and they emailed us that morning, the morning of the 8th, and told us, hey, we think there's going to be something coming, so be ready. So we were like, great. So we kind of waited on that day until later in the day, and later they gave us the details, and we were able to actually repro later on the 8th. We got an internal repro of this vulnerability. It was working. It was a real new vulnerability that worked on all versions of IE. And then on the 9th, we got to root cause the afternoon of the 9th. and we started looking for mitigations and workarounds, because we knew in this case, when there's a 0 day, we've got to release a advisory and help customers as much as we can right away. So we started looking for mitigations and workarounds. I think the first thing we came up with, this ended up being a data binding vulnerability. So we start kind of broad and go more specific. So the first version of our mitigation and workarounds said, hey, move the IE slider to high, which disables script. In this case, it was using heap spray, so that disabled the heap spray. It didn't stop the vulnerability, but it stopped the exploit because you couldn't heap spray. And we said also ACL msxml.dll. Now, in the real world, no one's going to be able to ACL msxml.dll. So that wasn't super useful yet, but it did give some initial mitigations and workarounds, and we put that in the first advisory on the 10th. So this was a couple days after we found out about vulnerability, and as we kind of monitored the situation, we looked at Watson crashes, we looked at different telemetry ways of knowing what's going on. We saw the slope going up. So this was getting picked up in exploit packs. It was getting installed. Or bad guys were using this to install malware in the real world. So it was a bad deal. So we decided, hey, we've got to go out of band. And we kind of compared this. The decision to go out of band is kind of interesting. We know, looking back, when it was a good idea, but you don't know, at this point, you're 2 days into it. You have no idea if it's going to keep going up or if it's just one group that used it and the rest of the people aren't going to figure it out. So it's kind of a gut check, but also we're starting to develop metrics around, okay, looking back at ANI, looking back at WMF, we agreed that both of those, after the fact, both of those were good ideas to go out of band with. So we looked at the beginning of the slope on those events, and that matched this. So we're like, okay, it's probably going to follow the same trajectory, so we've got to go out of band. So we started looking at the fix next. This actually was great because it was kind of a precise fix. It didn't affect a whole lot of other stuff, so it wasn't as important to do this full, like Mark was talking about, the full 2-month test pass. It would have been great to do, but in this case, we can get away without doing that because of the kind of fix that the product team wanted to make. And then we had, as you can see at the bottom there, is 4 days to hack for variation. So we were doing some stuff internally. By this time, the bug details were public too, so we actually enlisted some help outside the company. We talked to a couple of security researchers and asked them if they would help us hack for variations. Yeah. Okay, so remember when we first published the advisory, it said, hey, turn off script, disable MSXML, and really no one's going to do that. But as we kept working, so this doesn't show kind of a continuation, but we kept working on the mitigations and workarounds, and we came up with a little bit tighter. So it turns out you can actually disable or unregister or ACL oladb32.dll, and it's not going to break everybody. It's going to break all database-driven stuff in IE, but it won't break the world. So we revved the advisory with a second workaround was ACL oladb32.dll. And the next day, we actually came up with another idea that was even more specific. It was disable this row position object, which it wasn't used that much on the web, so it broke way less stuff than oladb32, but it still wasn't as precise as we wanted. But we revved the advisory again, and we actually posted a blog entry that talked about the different, so we've had, let's see, one more slide. We've had several different workaround options now, so we kind of categorize them on what they're good for. So some of the workarounds were really good for stopping the heap spray, like turning off script. You can't heap spray. Some of them were good for protecting against the vulnerability. So we kind of helped people make decisions on how to choose a good workaround strategy with the blog. And then the next day, let's see, that's going to go away, I think. There we go. So then on Saturday, we revved the advisory again. This was our final workaround. This was actually super specific, and it was disabling a functionality that really wasn't used that much on the web. So this is a pretty good workaround to use. So we revved the advisory again on Saturday. And actually on Saturday, we got our first packages from the product team. So we all went heads down, focused on trying to break the package and make sure that it was effective in stopping the exploits. So we had a few days of that. And then the bulletin shipped on that Tuesday morning at 10 a.m. So that's kind of the abbreviated test pass. You see there's no depth test pass here, no breadth test pass. It's just we did the minimum stuff we can do and get away with it and release a good update. Let's see. Actually, so just to kind of go over what the philosophy that you've kind of seen from Microsoft, we optimize for not breaking stuff. We have a process that we go through with every bulletin to find variants. We take all vulnerability reports seriously. We use a human for spam filtering. Let's see, was there any other points we wanted to bring out about this? Okay. So these are some blogs and whatnot, and we'll leave that up as we take questions. So any of us three are happy to take any questions you have about any topic. Go ahead.
Just out of curiosity, why do you stagger Windows releases from one? So why is there a 1 month gap between them?
Yeah, you mean the depth test pass and the breadth test pass? Yeah, there's only every month there's a depth. Or let's see, it only goes every other month. We don't do a depth test pass and a breadth test pass at the same time. All the packages go into the breadth test pass. That's kind of the value of the BTP. It tests all the packages together. Whereas the previous month, each package is being tested at the same time. So when we find bugs during that DTP, they don't reset the BTP. So we test all the packages separately. Hopefully we work out all the bugs there, and the BTP is kind of a last, okay, let's make sure all the packages work together. So they can't really go at the same time, and the product team asked for a month to do it, so you get every other month.
So it's rare you'll see a Windows bulletin back to back.
Yeah, you'll actually, if you graph them out, and we have a graph somewhere, you'll see the Windows bulletins goes up and down every other month. Yeah, you'll see a rhythmic cycle. And usually the even months are Windows bulletins and the odd months are not. Go ahead.
What are some of the criteria you use for scoring the exploitability?
Yeah. So it's 30 days after the update. So we think about one thing is we think about how likely is this bug going to have attention on it. So maybe it's super exploitable, but nobody in the world is using it or has that product installed. So that will lower the exploitability index because we don't think hackers are going to look at it because it's not that valuable of a bug. So that's one. If DEP and ASLR are enabled, that moves it down because it's pretty hard to exploit some of these bugs with DEP and ASLR. What are some of the other criteria, Mark? Yeah. Oh, sorry. Yeah. Go ahead.
So one of the factors is basically looking at just the nature of the bug. Like the one SMB bulletin that we shipped in January was rated critical in the bulletin because theoretically you could use it to get code execution. And basically the bug was overriding kernel memory beyond the bounds of a buffer with zeros. So the attacker didn't control what value was written, but potentially if they overwrite something interesting with a 0, they might be able to get code execution. We kind of looked at that and we thought, okay, well, how much control will the attacker have over the layout of memory in the kernel? And it turns out that it's really hard to kind of predict memory layout unless you're like physically on the box and whatever. So just the nature of the kind of exploit or the nature of the bug made it clear that getting that to be a reliable exploit within 30 days of the bulletin was not really a likely scenario. And we could lower the exploit indicator rating for that one.
In those cases where it's unclear, where it's not a sure shot, or you can't completely rule it out, do you actually POC exploits or try and POC them internally?
We don't really spend a lot of time internally doing POC exploits. We do work with partners through the exploit indicator program, and they basically they have expertise in doing vulnerability development. So they will look at the bug and kind of tell us, what their take is as an external sort of auditor.
Okay, and then that gets wrapped in.
That gets rolled into our rating. You first say.
How's the track record for the exploitability index?
It's actually been really good so far. The big thing to remember with exploitability index is that it's a 30-day snapshot. So like say 60 days, 90 days out after the bulletin gets released, the time to the time that attackers have to actually make POC more usable gets better. So the Bulletin severity ratings will always stay the same, but the exploitability index is really only good for about 30 days. But so far, yeah, it has been pretty straight on accurate.
Defense report.
Sorry.
iDefense actually looked at that too, and they posted a report maybe last week or so saying it was pretty good. So that had more detail in it, though. If you have more questions about that.
To what extent do you work with Apple in their efforts, to protect OS X and some of their products?
We really focus on just our own stuff. Yeah. Go ahead.
Well, actually, I mean, real quick though, it's like we do reach out to other third-party vendors and stuff as well, right? And so if we have vulnerabilities that go across platforms or across OSs, then we make sure that we don't zero-day or anybody else either. And so, I mean, we do kind of reach out to everybody else as well. And so part of the broad test pass is also common user desktop scenarios. So we make sure that any updates that we do don't break things like, Adobe Flash or something like that. Things that we know that most users are going to have on their systems as well.
I guess I was wondering, with Windows running on Macs now, are there any security issues that you guys need to watch out for?
I mean, for the most part, that stuff kind of stays with the OS, and so we're okay there. But things like QuickTime and other things like that, we will kind of reach out. Sure. So the question was, out of the 1,000 emails, why do we only wind up with 70 bulletins? A lot of times the vulnerabilities we'll crack a case on an issue where we really need to just spend the time to investigate. And so during the investigation process, we wind up finding out that there's a lot of mitigations, or there's ways that the vulnerability reported really doesn't actually equate to remote code execution or system DOS, things like that. It could just be stability bugs or functionality issues, things like that. And a lot of times those cases will wind up shipping in either a service pack or the next version, or a roll-up for that component. But the bar for a security release or a security bulletin release is actually pretty high. And so it's also to make sure that we don't kind of keep our customers on a treadmill of having to do tons of reboots and things like that as well.
Let me just add on to that real quick. So we have a bug bar that we have every class of bug and the severity or the amplification or the likelihood. Every bug that comes in is graded against that. And if it meets the bar, it goes into the security update. And if it doesn't meet the bar, it doesn't. So go ahead.
Last question, just for time.
Okay, thanks.
Where do kernel bugs these days stand with respect to that bar? Given that hackers are starting to do kernel-level exploits through browsers, sort of multi-stage exploits.
Yeah, it's the attack vector that decides that. If it's, we just released a kernel bug yesterday that was rated critical because it was reachable by EMF. So EMF, there's a polygon method that reached into the kernel, and that was critical because there was a browse in your own vulnerability. A lot of these kernel bugs will be a local elevation of privilege. Local EOP is important. I mean, it's super clear cut in the bug bar. It's easy to grade. Yeah. Okay, that's it. Thanks.
All right, thank you.
Oh, we're going to be around the whole conference, so please come talk to us if you want.